So welcome everyone. This is the first seminar of hopefully like a series that we'll be doing in partnership with Muk3D. My name is Simon Ogudé-Chambert. The majority of the work that we do with Simplexit is in the field of mine water management, but also mine waste, and we're also like a reseller for and support provider for Muk3D for Africa and Europe. And as I mentioned, this is the first of hopefully a series of seminar. The idea is really to explore like the various insights that I might have and experiences gained from using Muk3D in different type of mining applications. While we'll be showcasing some of the Muk3D's functionality, the primary goal of the seminar is to share practical knowledge. So it's not a step-by-step tutorial. The goal is to spark discussions, like share some of the challenges and maybe sometimes highlight some of the creative ways in which Muk3D can be used. So today's session, the focus is on sequencing the operations of when it comes to tailings planning and how we can model that sequencing in Muk3D. We look at a range of different type of workflows that can be done. But just like to give you like a very basic kind of like understanding of what we're talking about. So Muk3D is used to model the geometric life of tailings storage facilities. And so the idea is to look not at the rheological scale, but at a bit scale level. And so from a slope, we estimate what sort of volumes of water we have in the system, what sort of tailings is being deposited. And according to the slopes that we have, then the model will goal seek and search for what is the correct discharge elevation that will lead to the specific volume that we're trying to deposit. Once we've done the deposition, before we run into the next step, the idea is that we want to first like trying to find out, well, are we capable of contain this? So do we need to actually raise the dam? And so if we do need to raise the dam, then we just build an additional containment. And then we can start again with doing some deposition. So as you can see, to do the planning is going to be a sequence of doing deposition runs. And then from time to time, we might need to raise the dams to actually add additional containment. What are we talking about when we talk in terms of planning? So it's a range of plans that we're looking at. It goes from like your long-term plan where you're really trying to ensure your overall capacity of your facility and put possible extensions to it. Then we look at medium-term plans where you're focusing on like different like 3 to 5 year schedules, and you need to budget for your constructions and plan as well the correct timings for that. And of course, this needs to align with the long-term strategy. And then short-term plan where you're now looking at more details in terms of your operational management and managing monthly to seasonal operations of it. So every time, according to the type of plan that you're trying to do, we'll be looking at different things from like looking at the overall geometry and capacity to looking more at like kind of like scheduling the various intermediate steps of raise and planning for capital expenditures. And then finally looking at sort of like adjusting weekly, monthly operations and deposition strategy. Okay, so I'm going to hop into it. These are the different workflows that we'll be looking at. We'll start with the most basic ones. It's how do you do your planning just manually? So you will do command by command. Then we look at some of the commands that exist that allows you to do directly automated sequencing, whether it's deposition only or deposition and raising of the dam. Then we'll go into the scripting, where we'll take what we've done in terms of doing manual deposition and we'll automate that process. And then finally, we'll look at Muk3D simulation, where now we start building an interface that allows you to run your simulations from that interface for your specific model. Okay, so manual planning. Muk3D is like a big toolbox with lots of tools available to do different designs. The idea is that you want to start building a workflow. And the workflow should be about how do you sequence your every steps? What do you do exactly? So typically, when you do your manual planning, it's three main steps that are occurring. Is you start with a specific topography. The first step will be to prepare for your new run. So in this case, it will be just to create a folder. Then assess, do you need to actually do some, do you have sufficient containment? Yes or no? If you don't, if you have got sufficient, is additional containment required? If it's no, you can directly do your deposition, otherwise you can erase your dam. And then finally, you'll evaluate what is your design criteria, and that will be your first step. So we'll do loops of creating a new run, raising the dam, do the deposition, and start over again. So let's go ahead. Okay, hold on. I'm just getting a message that someone is not seeing the screen. I'm just going to stop sharing and start sharing again. Just let me know if everyone can see the screen again. Okay. All right. So let's go ahead and we'll just move this window. So as I mentioned, what we'll do is we'll first start a deposition run. So we'll go to Who's Project, New Deposition Run. And the first staging that we'll do staging with elevation. So we'll stage it, we'll say we start at 105 meters, and then we'll start raising our dam to 110. So this first step just created the correct folder. And then from this folder, we'll start raising our dam to this elevation of 110 meters. So we go ahead and we already set up a template for it. So we can just go dam, raise your dam. We want to use this template and we want to raise the dam to 110 meters. We'll take the grid from the previous run or our initial grid that we might have got. And then in this case, we'll generate the discharge points automatically. So now it raised the dam. It's got now a new wall that's been built. It gives us how much volume we needed to actually fill that volume. So I could record that and put that maybe in an Excel spreadsheet. Now that I've raised the dam to 110, I'm going to fill it up with tailings because I'm only staging it with elevation. So I'm raising the dam, then I fill it up with tailings. So I'll go ahead, Who's single stream deposition. I'm going to put a pond in the middle of it. So I'm going to do fixed pond volume. And then I will use those models that we have here on top, which are called capacity models. And you just give it a specific elevation and it will fill the dam to that specific elevation. So in our case, we'll just use the contour as drawn. We'll take the grid that we've just created when we raised the dam. We'll take the discharge points that have been created automatically. And then for our pond, we'll give it a volume of 50,000 cubic meters. And we'll raise the initial guess, we don't know at which elevation. So I'll put 102. I just know that the maximum containment needs to be 110. So now I've raised my dam. I filled it up with tailings. So now I've got a new dam that's been filled up with tailings. I've got some volumes, so I know exactly how much volume I needed to, I could discharge from 105 to 110. In this case, the total volume that was discharged was 2.8 million cubic meters. And now I could go ahead and carry on. So I would go again, new deposition run. This time instead of 110, it becomes 115. It creates the folder. I'm ready to raise the dam again. So I'll do dam, raise the dam. I'm going to do less value for all fields. I just need to repeat it because now it's going to get simpler. It's going to be target will be at 115. I'm going to go pick up for my last run where not only I raised the dam to 110, but I filled it up with tailing. I'm going to go and get this output grid.mgrid. And then for I will still generate those discharge points. So now I've raised the dam and then I can carry on this process. I'm going to do it one last time. I'm going to now discharge some tailings on top of it. Same thing, I'm going to repeat less value for all fields. It's almost going to be the same things, except the pond elevation, the crest can go up to 115 now. and probably the start should be closer to 106. Okay, so now we filled it up with tailings again, and now we've done our first planning. We went from 105 to 110 to 115. I can just plot it rapidly. So I'm going to go to ooze, and I'm going to say load all output grids. And then I'm going to just do a cross-section through it so that we can have a look at it. And you can see we've raised the dam, and then we filled it up with tailings. We raised the dam, we filled it up with tailings, etc. Now this was staging with elevation. Staging with time might be a bit more complex because we don't always know whether or not we've got sufficient storage capacity within the dam. So there might be a bit of iteration that needs to happen. So let's go ahead and now we look at an example. This time it will be staging with time. So let's go this. So we're starting from the same situation again, where we've got this time in 2025. And I'm just going to load it so that you can see our starting point. So it's the same starting point, except that this time, instead of just filling it up with tailings, we're going to say, okay, we'll raise the dam, but first we'll try to deposit, let's say, 1.5 million cubic meters of tailings. So I'll go ahead and first go to dam templates, ooze, project, new deposition run. Here for the year, I'm going to put 2026. Really, this new deposition run is just about creating a cascade of folders. So you can use it in different ways. It doesn't need to be the year necessarily. Earlier on, I used 105, 110 as the elevations. And so this time, instead of staging with elevation, it's going to be staging with time, which correspond to this folder. I'm going to put it at 2026. So in 2026, we've got a dam that has been filled with tailings up to 105 meters, and we're first going to raise the dam. So we'll first say, okay, we'll raise the dam, and I'm going to raise the dam this time to 110. I don't know exactly at which elevation. I need to have it. So I'm going to put it a bit higher. I just know that I need to that I've got 1.5 million cubic meters of tailings that I'm going to be depositing over the next year. So my base grid will be stage with time 2025, the last grid from the last run. And I'm going to start at 110. And I'm going to see what is the, when I start doing the deposition, I'm going to see at which elevation does it correspond to, what sort of freeboard do I have, and then I'll make the estimate about what is the elevation for the dam crest. So we'll go to ooze. Same thing, I'll reuse the same models, but this time instead of using capacity models, where I just gave it an elevation and we were filling the tailings up to that elevation, this time we will use these sequencing models, which we have in these sections here. And so I will take my grid that I just created when I raised the dam to 110. I'm going to do my discharge points. And then my initial discharge elevation will be at I'm going to start at 107. And then I mentioned that I wanted to deposit over the next year 1.5 million cubic meters of tailings. I'll keep the same value, so I set 50,000 cubic meters. Currently, the dam crest is at 110, but we'll see whether or not we need to have this sort of dam raise. And then I click on OK. So now I'm depositing exactly 1.5 million cubic meters. I can see once I've raised my dam, once I've done my deposition of 1.5 million cubic meters here, then my discharge elevation currently is at 107.071. So that gives me currently a freeboard. If you to define the freeboard as from like the top of the discharge to the crest at 3 meters. Maybe, you know, from a design criteria, I need to have like 2 meters of freeboard, for example. So maybe I don't need to actually have my dam at 110. In this case, maybe it was sufficient to just raise the dam to 110. So I'll do the same thing, but instead of 110, I'm going to make it 109 because I know that 107 is probably sufficient. So I'm going to go ahead, raise my dam, and then I'll do the process again. I'm going to overwrite those files. So I've raised the dam on top of it, and then I'm going to do the deposition. I'll rerun exactly the same thing. The only difference is that my maximum is at 109. And now you can see that I've got my discharge elevation is at 107.2 and my crest is at 109. So I've got about 2 meters of freeboard, and then I would carry on like going like this. So same thing, I would repeat the process every time, create a new year. And it's not all the time that I might do some raising of the dam. I might be doing like several runs where I would discharge some tailings, and then at some point I need to raise the dam. As you can see, it can be quite time consuming because now you're doing step by step. So you're doing the folder creation, you're assessing whether or not you need to raise your dam, you do your deposition, and then you repeat the process over the next folder. So this is really practical. It's essential even to build your workflows. So you need to actually build your workflows based on, sorry, oops. This is essential to really build your workflows because you've got complete control over the changes and the sequences that you might want to do. It's suited for complex or unusual designs requiring careful step-by-step manipulation, and it's really essential. It's really you putting all the commands of what you want to be doing. In this case, we started with something very simple: create a folder, raise the dam, do the deposition, but potentially you could do more things. You can evaluate various design criteria, what's your actual freeboard in terms of volume, what could be maybe the distance from the dam to the pond, the dam crest to the pond, or various other criteria that you might have. The main issue with it is it's highly labor intensive because you need to do everything manually, including the import of all the inputs, the selection of the files, and then all the outputs from the model, you also need to manually export them. So over a long period of time, this becomes very difficult to work with it. And then you need to use other tools. So that's what we'll be looking at. A couple of other tools that we have available. There are some tools that are automated. So they allow you to do an automated sequencing of commands. First one is called auto staging. And all it does is it raises the dam, it fills it up with tailings, so you don't have any control about how much you can deposit. And then it goes to the next sequence over and over again. The second one is called stage storage elevation curves. And this time you don't do any of the raising of the dam. However, you can provide it with different elevation for the discharge. And then it will go ahead and do in sequence the deposition on top of each other. So for two different purposes. The first one we'll be looking at is auto staging. As I was saying, you raise the dam and then you fill it up with tailings. So I'll just take this folder here. To actually use this, you need to have two things in place. First, you need to have a topography. And then I'll press T for transparency. And you can see below it, I've got the toe of a dam. So it's T for transparency and O for opaque to actually see what you have below it. So in this case, this toe. And when you use auto staging, you don't have that many options in terms of control of the pond. You can either have like no pond, a fixed freeboard, or yeah, and that's it. No pond or fixed freeboard. And you can use different type of construction. So it can be upstream construction, central, centerline, or downstream construction. So let's do an example with an upstream construction. Let's say you wanted to, you've got a crest width of 20 meters, a downstream slope of 1 in 3. That's the overall slope characteristics of your construction type. Then for the pond, the only input that you have is the freeboard. So let's say you want like 3 meters of freeboard. And then finally, we'll have what is the sequence that you're trying to run. So let's say we want to actually raise the dam from 100 meters, 110 meters, all the way to, let's say, 122 meters. And we'll do every step of 3. So we'll say 110, 113, 116, 119, and then 122. With discharge points every 150 meters, and then a bit freeboard of 1 meter, meaning that we will do the deposition 1 meter lower than the dam crest. It will be called scenario 1, and then I'll just click on OK. It will ask me to select my topography, select my toe of the dam, and then we'll raise the dam. And then very quickly, you'll see it went and did all the sequencing. It went to 110, it went to 113, 116, 119, 122. It provided me with a folder. In that folder, there's an Excel sheet. The Excel sheet contains all the increments in terms of your dam wall volume and in terms of your tailings that you needed to fill in for that specific increment. So you can see every time for each increment how much you need to actually build your wall. And remember this example, this is an upstream construction. So as we raising the dam, we fill it up with tailings, but when we actually raise on top of the previous tailings that's been deposited. So that is being taken into account. So very rapidly, you can see we stage all of those. I'm just going to close that and show you the results. So I'm just going to load all the grids that have been created. And you can see it went very rapidly to actually create them. And then we now have the various stages where we raised the dam, filled it up with tailings, raised the dam again, filled it up with tailings. Those grids are only once they filled with tailings. But you can see how rapidly we were able to do that. Now, this is a very practical tool. It's limited in practice for various reasons. And in general, this can be used for very simple designs. When you look at mid to long-term planning, where actually like the detail of the operation is not as important. But one, it assumes uniform deposition around the perimeter because it will be used the deposition like all around that perimeter. Then you've got very limited ability to customize both your deposition and your pond geometry. It's only using like a freeboard. And so overall, it's not ideal for complex and multi-stream scenarios. It's good for like some rapid assessment. The second tool, which is also a bit similar, which is called now tailing storage curves. This time, we are not sequencing the dam and filling up with tailings. We go at a finer grain, where now we're just looking at giving specific elevations, and then it will just do the deposition at those specific elevations. So let's go ahead. We'll take this, I think here. So in this case, we'll take another okay, we'll load this project. So in this case, we've got a downstream construction, and we want to see what is the stage storage elevation once you start raising once you start doing your deposition all along the wall of the dam. So we'll go ahead and way before we went to ooze auto staging, this time we go to ooze tailing storage elevation curves. Same thing, limited options in terms of the sort of pond model that you might want to use. So it's either no pond or a fixed freeboard. We'll use a fixed freeboard. The algorithm we'll want to use for this one is going to be called flow down slope. And so in here, we'll need to select what is the topography that we're starting with. So in this case, is that Valley Dam. I'm gonna do the deposition of this specific tailings. I'm gonna just pick up my deposition line. For the pond, we'll use this time in this example a freeboard of 9 meters and the maximum containment elevation, I believe, for this grid is 435. So now here, elevation, we need to decide, well, what elevation do we need to put it? And so there's different ways. We can either set it up as with semi-columns. So we might say, well, I want to test at 422, 424, and 427, for example. So I might want to go ahead and I say, well, I want to actually do the deposition at this specific elevation. Go ahead. So it's going to go ahead and it's going to do the deposition at 422. Then it's going to do the sequence where it starts depositing on top of the previous grid at 424. And then it's going to do the same thing as 427. Same thing, ultimately, it provides you with a summary sheet. This time is a bit different because it doesn't contain the raising of the dam wall. But it gives you like the volume that you have for each of those layers of tailings that you've been depositing at each of those elevations. In this case, I just selected manually 422, 424, 427. I might want to do it a bit differently. So I might want to say, okay, I want to delete all of that. Let me see if Excel is okay. So this time I'm going to go auto staging and no pond, fixed freeboard, sorry, tailing storage, fixed freeboard, flow down dam slope. And this time, instead of selecting with a semicolon, I might want to say, well, I want to go from 422 to 430, and I want to go every 2 steps. So every 2 meters. So now it's going to go 422, 424, 426, 428, etc. Click on OK. And then it starts doing the deposition. So I'm just going to load all of them. And now, if you just take a screenshot here, I'm going to change the aspect ratio. I'm going to make it 20. So you can see now we've done the deposition. It's given to us in sequences. And we build on top of it. So the sequencing is done automatically through that command. So when is it useful? Well, one is useful once you've got a downstream construction, because as you're building your downstream construction, the coupling of raising the dam together with the deposition is actually fairly independent, because so long as you've got a slope here, it's going to be the same volume that you require. When it comes to upstream and central construction, I wouldn't use it in most of the cases, because of course, as you're building on top of your tailings, and so your volume calculation will be affected by an approach like this. So once again, it's for simple specific conditions that you can use something like that. But it is limited, so it allows you to do very rapid estimates of those layers of tailings that you might want to deposit, but it's for fairly basic single stream deposition. Okay, so now we've gone through going step by step manually. That was the first one. Then we looked at tools that are available, but they're mostly useful for fairly simple designs. And so the last one, the next step is now to go into scripting. So scripting is now, we have some commands that we've lined up and that we keep on repeating, like we've done earlier on when we did the manual deposition. Well, instead of repeating them, let's put them inside of a script and we let the script do all those things for us. So I'm just going to show you an example, and then I'll just show you how you build it in practice. So in this example, I will I've got a script that's already been written up. I just need to clean up a bit this. So I've got a script here that's already been created. The steps that we'll be going through is we'll be raising the dam, fill it up with tailings, and then we'll edit a bit we'll edit a bit the imagery, and then we'll take a screenshot of it. So what we'll do is we'll do similarly to what we did early on. New deposition run, we'll raise the dam, we'll fill it up with tailings, then we'll do a bit of editing. So we'll edit the texture, change the view, take a snapshot, and then clear the graphics. So we'll first record a macro so that we can then use it, and then we'll put it in a loop. I'm first going to show you the script running, and then after we can look at how you get to actually build the script itself. So I'm just going to go ahead. So you see I just drag it, and automatically it starts raising my dam, filling it up with tailings, do some editing of the image, take a snapshot, and then it'll carry on for the next step. So all we did is we took a series of commands, and we let the script put them together, and we'll repeat it. So we only need to write it once, and then we'll put in a loop, and then it can do it all by itself. So now, of course, it's got lots of advantages. The main one being that this is all systematized. So you don't have to every time do manually your import of data and then your running of commands. It's all automated. You'll see at the end of this small script, it actually creates a small animation. This is a fairly sort of like rapid visualization. I'm still busy processing it. This is very coarse. Of course, like if we had a bit more time, we could do a lot better quality sort of rendering. So how do we go about doing something like that? So I've just recorded a small video to actually show you the steps. So we'll start from the same thing where we've got a folder at 105, but this time we'll start from scratch where we'll actually record a macro. So to record a macro, we'll click on that button here, the red button. What the macro will do is it will record every sequences of commands that have been done directly inside of Muk3D. So we'll start the recording. You need to give it like a specific name for your Python script. And first step, so the macro is starting to record. First step, we create a new folder. So we'll go new deposition. We'll create a folder at 110. Then we'll start raising the dam. So we'll go to dam, raise the dam. We'll repeat the same process. So we'll give it the elevation. I'm going to fasten it. So we raise the dam, we fill it up with tailings. And that's all what we've done earlier on. So I'm just going to kind of like fast forward it a little bit. So we raise the dam, we fill it up with tailings. And right at the end, we'll just let it run. And we will stop the recording. We'll first clear the graphics, and then we'll stop the recording. So once we stop the recording, it creates a file. It's a Python file. Currently, it's just like seen as a text file. You can use it like you can use like more advanced tools to actually see the actual color coding of it. So in my case, I'm using Sublime Text, but there's plenty of other tools like Notepad++ or PyCharms or Visual Studio Code that you can use for that. It's just a much clearer way to actually see it, and you can see all the comments that have been recorded. So we did a new deposition run, then we raised the dam, and then you can see there's an additional comment that's been done when we actually did the deposition. So we want to put all of that inside of a loop. So we'll go ahead and say, okay, let's create a variable called a list of elevation. The variables will go from 110 to 115 to 120, for example. And then we put everything inside of a loop. So we'll say for each elevation that we encounter inside of that list called list elevation, lie elevation, we'll just indent it so that it's actually within the loop, which is the approach in Python to actually put it in the loop. And we need to change some of those things. So now, every time we go in the loop, when we do the new deposition run, the name needs to be our elevation. So at 110, the folder will be 110. At 115, the folder will be in 115. Then we raise the dam. We'll raise the dam to the elevation that we encountered. So in this case, we'll raise the dam to 115. Okay, now at the very beginning, we start with our original initial state was at 105. So we'll just create like a variable called 105. And then we can say actually every time you raise the dam, you will raise the dam based on the previous year output grid. So we'll go and pick up the previous year output grid. Finally, every time we do the deposition, the maximum pond elevation will be that elevation at which we've just raised it. And then the pond elevation itself, we don't know, we need to give it a first guess. I'm just going to say it's the crest minus 5 Nm. Of course, we could optimize that, and this is just a rapid one. And then finally, when we clear the graphics, we'll just say we want every time to clear the graphics without us checking. So I'll just change false to true. And then finally, at the end of my loop, I'll change the elevation so that the previous run now becomes the next one. So 105 becomes 110. Okay, and now once you've got the script, you just grab it, and then it will go and do the specific comments that you just said. So for us, it was going from 1.5 to 110 to 115. And every time we raise the dam and we filled it up with tailings. Okay, so we've seen now just raising the dam and fill it up with tailings. It could be more complex than that. This is just like really to start. For example, we could add additional components. So earlier on, so I'm just going to show you first the results of what we've just done. It's actually a bit similar to what we would have done with auto staging, except that we've got complete control now over each of the steps. And so we could complexify it a lot more using like multi-stream distribution, deposition, for example, or like different type, more complex sort of like wall raise or different sections of the wall. But let's complexify it. So maybe we want to add additional thing like post-processing. So what we'll do is we'll record a new macro. So we'll go ahead and we'll just call it script additions. And this time we'll go and append some overlays with colors. So we'll take the texture, the imagery that we have currently, and then every time we'll give it a new name. The new name will have the new elevation. And then we'll change the color. So we'll use the actual tailings outline and the dam footprint to actually change the coloring. So I'll just add a couple of colors rapidly. And so that will just create a new file, and that new file is called new imagery 110. And you'll see that once I grab it, actually this imagery now has got the shape. I'll just give it a specific view and I'll save this as an image. So now it's saved as an image, and I can integrate all that code. So I'll take all that code and now I'll add it to my previous code that I had before. So now I'm starting to complexify it. I had a very basic workflow at the beginning. Now I'll just add a bit of post-processing. So now same thing, I need to change a little bit. So I need to do minor modification every time so that instead of just working once, it works now for different elevations as I go through a list of elevations. And same thing, this could be a bit more complex. This time I just rename the imagery with the correct name. And then I'll just add as well I will just drape the image, and then that's it, I think. Yeah, I just will save at the end the image. Okay, so now we grab it, we do the same thing, but instead of just doing the raising of the dam and the deposition, we also do the actual mapping of the actual editing of the image. Okay, so this is for doing macros and scripts that allows you to now like put all the comments that you have inside of Muk3D that you typically do manually. Now you actually line them up in a way. So you line them up, they're already inside of the script, and it takes care of what it should do inside of Muk3D. Big advantage of it is it's highly systematic. So once you have it set up and you know it works, you can just like let it run. So overall, it reduces the risk of human errors in terms of, you know, inputs, choosing the right commands and outputs. Of course, disadvantage is it requires a bit of familiarity with scripting. You only because you can actually record macros, you only need to have like limited skills when it comes to Python to be able to actually run fairly complex scripts. But of course, it's not because it's automated that you need to believe it. You need to like also still observe and validate, you know, the logic of what's actually happening. Okay, final steps. It's looking at Muk3D simulation with Excel and then Muk3D simulation with GoalSim. I'm not going to go into the detail of them, but basically we're taking all the steps that we've learned up to here, meaning that we've learned how to do all the deposition manually inside of Muk3D. We picked it up and put it inside of a script. The main difference now with Muk3D simulation is you've got now an Excel sheet, which is your input and outputs for all your runs. So you have that Excel sheet, and then you run on different columns or rows according to how you've sequenced it. Maybe you're doing a monthly planning, so every column represents a month. It might be annual planning, and each year represent a row. And then Muk3D will read that data for each specific month that you might want to run. It will select what operation it needs to do, and then it will populate that. So the idea is that you've got now a dashboard, which is a model for your specific site that can create specific scenarios, and then you run everything from there. As I said, I'm not going to go into the detail of it. I think I've got a okay. So, for example, I don't know, let me see. I don't know if I set it up. So we'll just go ahead, open this. We'll open a spreadsheet. In this case, we've got, say, some values here. You've got some values in terms of what is the mass that you're depositing on two different lines. You've got A1 and B, and then there's actually a split in the tailings. So you've got actually deposition in three different tailings line. You've got an A1 volume, A2, and B sections. So we're doing all that deposition. Those are the volumes that are being read directly by Muk3D, and then Muk3D will populate the information in here. So I'm not sure if I've got it set up here. I'm just going to try first, otherwise I'll just show you the video. So let's just go ahead and think forth. So you see here I picked up, I'm doing the deposition on this side here. So we'll get the values populated here. So it takes a bit of time because the simulation actually runs multi-stream deposition, and it's got three different lines. So we'll just let it run for once and see that it actually populates the data here. And then I'll show you a video afterwards. And that sort of like is accelerated. I probably should have shown an example that's a bit quicker to run. Okay, I'll show you a video, and then in the meantime, it's still running. Yeah, I'll show you a video, and then we can have a look at the results after. Okay, is it populating here? No. Okay, so let's do the video because we're still running. I don't want to waste some time. We'll just have a look at it afterwards. So this is an accelerated video, and you can see here that it starts populating your data as it goes along. And that this is just accelerated. So at any point of time, you might say, well, actually, I'm not happy with the results or some of those design criteria. So you might want to rerun it. So you might say, okay, I'm going to change actually where I'm doing the deposition, and then I can rerun it from specifically July 2023. So it takes into account the whole sequencing already in there. I want to leave a few minutes for questions, so I'm just going to very quickly kind of like go through Muk3D with GoldSim. This is now even more advanced than Excel. I specifically would recommend it mostly for research purposes because it's highly demanding in terms of time of computation. And this time, instead of running it with fixed inputs like we have inside of an Excel spreadsheet, okay, didn't run them properly. Instead of doing the deposition with fixed input that we have here, with Muk3D simulation, we now have multiple simulation. Each input can be taken as a distribution, an uncertain input. So same thing. This is a video where here we model like a water balance on the side, and then every single month we actually send information to Muk3D so that it can rerun, evaluate what is the state storage curves, and then that is being fed back into GoldSim. So now you've got the interaction between the two. Really, what I'm just going to show you. Oh, this is not going to work. I just need to open it with the correct version of GoldSim. Okay, so really the results is now statistical. So we run the model multiple times, and here it shows us, for example, in red, what is the capacity at crest level. In blue, we've got the elevation of the discharge. In green is the pond elevation. And we simulated it multiple times with different rainfall sequences, with different tonnages, but based on specific distribution. So each future gave us different results, but ultimately we can look at it from a probability level. So now instead of just planning for, this is the raise of the dam wall, you can see that the dam wall needs to be at 420 meters. Most likely this will be during the early period of January 2020 of 2026, but it could be as early as late 2025 or as late as early as late 2025 or as late as mid 2027. So now you're doing your planning, but you're also doing your planning considering the risk as well, and what is the likeliness of being at specific levels and elevations. So this is kind of like in summary the various options that are available. Of course, this is more like guidelines. There's plenty of different ways that it can be done, and it can always be more complexified. But in general, these are the 6 sort of ways that can be done. It's completely manual, auto staging and Tailings storage elevation curves, which are like automated but simple options. Scripting now gives you the possibility to do whatever you want, like do whatever workflows you'd like to do. And then finally, Muk3D simulation allows you to have like an actual proper interface so that you can actually interact straight from that interface, and you've got a model that's specific for your specific site. So that sort of covers up the list of workflows. There's still a few minutes, so I'll just open it to the floor. If you've got any question, just raise your hand and I'll unmute you. Is there any questions? Yes, Gregory. Yes, go ahead. Oops.
Hi, Simon. How are you? My question is so as part of the gold sim simulations, you can assign certain probabilities towards, I don't know, materials and geometries and things like that. For something like the profile of your compound slope for the beach, could you also assign a probabilistic value to that compound slope?
Yeah. So in that model here that I just showed you, actually it has got that every time. I think that I don't have the model here actually, but every time in this case, so you've got, so in terms of scripting, what I showed today was directly recording a macro, and it provides you with a comment. There's also an API. So as part of that API, there's a number of functions that you can use. So this is the API. And the ooze, you can create compound slope definition. Sorry, where was it? I went too quick. Create compound slope definition. So you can create basically on the run a compound slope. So you can have Muk3D to generate GoldSim to generate specific distribution. They can be correlated according to the different segments that you have within your compound. And then at every run, it will actually take those new inputs and create it according to this. So it can change either within the actual simulation, the actual realization of the future, or it can be across realization. So depending on if it's you're trying to model some kind of like variability, or if it's more like some kind of uncertainty of your knowledge for the overall sort of like curve of your tailing slope.
Great, thank you, Simon.
Sure. Any other person? So I think I'm gonna sort of, there's still 5 more minutes. I'll just show you maybe one last video. So before I did mention that, you know, scripting can be very valuable for your sequencing of operations and creating workflows for that, but also it can be used for other purposes, like including creating new commands. So for example, this is just another example that I've been working on. I was just like playing about with it. And there's not a specific script to actually do the dry stack deposition. So there's not a specific command that can do that. But actually, if you sort of like put various commands together, you can actually fairly like simulate something that could be happening. So this is just to emphasize that you can do scripting to actually just automate sequence of workflows, things that you do regularly, but that sequence of workflows can be itself like a new command altogether. So in this case, this is just an example to kind of work out how would the tailing step sort of like develop, and it's got like specific slopes that you can have both, you know, as you advance and on the side as well. So this is just an example of how you can use scripting to sort of expand the capabilities of what can be done. Miguel, I see you've got a question. Let me just unmute you. Yeah, Miguel?
Yep. Hi, Simon. Yeah, thanks for sharing. Very nice workflow in general that you share in there. My question is regarding the learning curve, because and time frame, because you put it there very nicely. As at the end of the day, when someone gets into Muk3D, you start with the manual work, and then as you learn, you make those models more complex, like automating and then scripting and then simulation. So it can be understood as a learning curve, right? So
Yeah.
what would be the time frame, more or less, give or take, to get to that level of understanding?
Well, I mean, there's always depths. It's a bit difficult to put timeframes onto it. I mean, typically when you start with Muk3D, you want to start learning about what are the commands that are available. So I would not dive into scripting like at the very beginning for sure. But you can see rapidly that there are commands that you regularly use. And process workflows that you constantly are doing. So that's when as I was saying, learning the basic of macro scripting with Muk3D is fairly easy. You don't need to have like an advanced knowledge of
Scripting.
But of course, you start with manual planning and using those automated tools. This is really the basic and the essence of it. And then you start just recording the macros. And once you start recording the macros, you can start as well doing your own scripts and start diving into the Muk3D API that I just showed you, that contains a whole bunch of commands that you can use within your script and expand really like by a lot what can be done. And then Muk3D simulation, to set it up is time consuming. But once you have it set, you can on site just, play and replay the model using different scenarios, different options that you're selecting, because now you're just playing with your interface. You're not actually diving into the code. So it takes some time to set it up, but once you have it on site where you know that every 3 months you need to do a quarterly planning and you got to revisit, several years of deposition runs, well, you can do that like automatically. So the idea is to start with something very simple, start automating, and then ultimately try to get to a place where your site is just, you've got an interface for it. You just play through the interface for most of the usages.
Yeah. So like you show those stage capacity curves where when you run it on GoldSim, there is a worst case scenarios, and then there is the darkest in the middle, right? It's like the most probable outcome.
Yeah.
Or similarly, we can have like a learning curve. It's like, it could take between, I don't know.
Yeah, you could look at it like that as well.
1 year.
But really the idea of those seminars is going to try to kind of like decrease your entry level into those tools. So as I was mentioning, this is just the first of a series of seminars. I'm going to try to do them quarterly at this stage and see how it goes. I'll put out like a handout that's got sort of a summary of those tools, like a PDF handout. I'm still kind of like finishing it, and there'll be a replay of the webinar as well. So thank you everyone for attending. I really appreciate, and hopefully see you next time.
Thank you.